All right. So again, today we are starting chapter 8. We're going to start with section 8-2. The main reason for that is that section 8-2 covers Pythagorean Theorem, which you should have had some exposure to in middle school, which makes it a easier thing to teach virtually, or at least to introduce virtually, than the other stuff in chapter 8, which should all be brand new material. So we're going to start with section 8-2, which is the Pythagorean Theorem. We'll start off by actually writing out the Pythagorean Theorem in words. Now, if you printed your notes early this morning, there were some typos. I'll try to point those out. I fixed them and I replaced the file on Google Classroom about 10 minutes ago. So if you just printed the notes, they might be fine. So the Pythagorean theorem reads, in any right triangle, and that is a key thing here, the Pythagorean theorem only applies to right triangles, ABC, with side lengths of A, B, and C. That originally was one of the typos. So as shown over there on the right side, so here in this picture, we've got a right triangle with side lengths of A, B, and C. The sum of the squares of the lengths of the legs, and that's a lot of ofs, so that can be very confusing, very wordy, must equal the square of the length of the hypotenuse. Now, that is a whole lot of words. What it boils down to is this. Every right triangle, if we locate the right angle and go across the triangle, that is how we find our hypotenuse. The other two sides of the triangle are known as the legs. We've discussed this already back when we were proving triangles were congruent because we had that hypleg theorem. So hopefully we all already know how to find the hypotenuse, but that is the key thing here. And what the Pythagorean theorem boils down to is a very simple equation. In that picture over here, in this picture, we have three side lengths, A, B, and C, C being the hypotenuse. The Pythagorean theorem states that A squared plus B squared must equal C squared. So what it boils down to is that in every single right triangle where C is the hypotenuse, A squared plus B squared must equal C squared. Okay, that's the rule we're working with today. A squared plus B squared equals C squared. So we're going to do 4 examples of using the Pythagorean theorem to find a missing side length. One of those 4 questions is formatted to look like an SAT question because a vast majority, if not all of you, have to get a certain score on the SAT to graduate from high school in Indiana now. So we need to be preparing for the SAT, and we're going to be embedding these sort of questions into our notes and assignments and tests for the foreseeable future. So here we go. Any questions on the theorem before we advance? A squared plus B squared equals C squared. Any questions on how to find the hypotenuse? Anything like that? You can type in the chat. You can unmute. Okay, then. Let's go ahead and try one then. So here is an example of what we're being asked to do, and there was a minor typo in that I didn't have the word length spelled correctly in the original version of this that I didn't notice till after I'd already posted it, but that's okay, it's fixed now. But find the measure of the side length labeled X in the right triangle. Round your answer to the nearest hundredth, that's 2 decimal places if necessary. So again, the key thing for Pythagorean theorem, the key thing that kids do wrong, the mistake that most kids make, is they identify the hypotenuse incorrectly. So the big thing here is we need to figure out which one of these 3 things is the hypotenuse. So which measurement in that picture, 6, 15, or X, which one is the hypotenuse?
X.
Yep, it's X. So we go to the right angle, and we go across the triangle. that tells us that the x is our hypotenuse, or C. Okay? We've got to be able to do that flawlessly, not just for this, but for the rest of the chapter as well. You've got to be able to identify the hypotenuse every single time. Now, the other two numbers, 6 and 15, those are the legs. It does not matter which one you call A and which one you call B. Now, your assignment is formatted so that you will have to tell me the values of A, B, and C. So I'm going to try to set up our notes here to look exactly like what I'm looking for on the homework so that we will know exactly what we need to fill out. Okay? So A is 6, B is 15, and C is X. We are then going to plug into our Pythagorean theorem, which is A squared plus B squared equals C squared. So that would be 6 squared plus 15 squared equals X squared. Now this is it's just an equation. We've solved a lot of equations this year. So the basic idea is we're going to solve for X. We're going to get X by itself. So we start by doing 6 squared, which would be 36. 6 times 6 is 36. And 15 squared. 15 times 15 is 225. That still equals X squared. Those are like terms, so we add them together. 36 plus 225 is 261. And here's the one point where I worry about us not really being 100% sure about how to solve. How do we solve that equation for X? We have X squared equals 261. So how do we get X? You can unmute and answer me. You can type in the chat. How do we solve for X? X squared equals 261. What do we do? How do we get X by itself? How do we undo an exponent?
Don't you have to like cancel out the X or something?
Well, we got to get rid of the exponent. We got to get rid of the 2. There you go. Good job, June. We need to take the square root. Okay? So X is going to be the square root of 261. So everybody's got these yellow calculators. I'm putting it up in front of my camera that's not attached to my microphone. Okay? So on the yellow calculator, we're going to hit second and then X squared. Okay, those are going to be our keystrokes here. We're going to hit second, and then we're going to hit the X squared button. Right above that in green, you'll see the square root. Type in 261, and then hit the enter button. Okay, those are the keystrokes. So you're going to type in 261, hit enter. Now, when you do that, the first thing that your calculator does is it prints the reduced root. 3 root 29 is what prints out of the calculator. Okay? But notice what the directions tell us to do. The directions are saying round your answer to the nearest hundredth. So we need that to be a decimal. How do we turn numbers that are not decimals into decimals on our calculator? What button do we hit? Anybody? Button looks like this. It's right above enter. It has 2 black triangles on it. This is the convert button. So we're going to hit that button. And what that will do is it'll convert 3 root 29 into a decimal, 16.155494442, but we don't care about any of that. We only care about the first 3 digits on the calculator. And the reason for that is the 3rd digit tells us how to round the 2nd digit. So with that being a 5, show me on your cameras with a thumb up or a thumb down, which way are we going to round the 2nd digit, up or down? Good. Got a couple people on their camera showing me. That's good. We are going to, because that is a 5, that tells us to round up. So we are going to round up. And this turns into 16.16. And then the last thing we need are units. This problem, the units are meters. So our answer would be 16.16 meters. Okay, so that's how we approach these problems. We solve for the missing side length, and then we round to 2 decimal places. Okay? So, any questions before we advance to the second example? Unmute and ask. You can type it in the chat. Any questions before we advance to the second example? Can't wait to have you guys back in classroom so I can be like, I know somebody has a question, and just harass you until somebody asks me a question. We're okay? Okay. Wait. How do you solve without a calculator? Well, Cooper, without a calculator, you're going to have a tough time. Your phone calculator will go straight to the decimal. So you could always use your cell phone. It would not do the reduced root portion. It would just go straight to the decimal. And then you would just need to round. Usually, whatever your calculator app is, if you turn your phone sideways, it turns it into a scientific calculator, and you should be able to use that. Okay, so short answer is you can't. You need a calculator for these problems. Okay, unless they work out evenly, then you might just be able to do it in your head. But not very many of them do in high school. Okay, so you're going to need a calculator, which is why we gave you one. So hopefully everybody still has their calculator. All right, on to the second example. So here we go. Now this example is a little bit different. Not a lot different, but a little bit different. The reason it's a little bit different is because our x is not the hypotenuse. Which number there is the hypotenuse? The 11. Great, very good. Okay. Again, we go to the right angle. We find the right angle. We go across the triangle, and that is where we find the hypotenuse. So C is 11, which means the other two sides, it doesn't matter which one we call A and which one we call B. So we're going to use A as X, B is 9, C is 11. And if you switch the X and the 9, it makes absolutely no difference. You'll get exactly the same work and exactly the same answer. Set up the Pythagorean Theorem, A squared plus B squared equals C squared. So that would be X squared plus 9 squared equals 11 squared. Now this is different because the variable is not by itself. So when we go to solve this, 9 squared is 81. 9 times 9 is 81. And 11 squared is 121. 11 times 11 is 121. Now to solve this is not as simple of an equation as the last problem. We need to subtract 81 from each side, which would give us that x squared is equal to 40. And then to get rid of the squared, we need to do what? How do we get x? We take the square root. Very, very good. Okay, so we take the square root of 40. So x is going to be the square root of 40, which is not a perfect square, so it will not come out evenly. Again, when you put it in the calculator, you're going to get the reduced root. We're not really even interested in that, so we need to hit the convert button. Okay, the square root of 40 comes out as 2 root 10. And when we convert that, that is 6.324. And again, we only care about the first 3 digits because we look at that third digit to tell us how to round the second digit. The 4 would mean that we would round down or just chop off the rest of the decimal after that. So x would be 6.32. And then we just need our units, which are feet. Okay, so there's only one very slight difference in this example from the last one, and that is that we have to subtract the 81 from the 121 and then take the square root. Okay? So either way, we're solving for x. We're solving for x. Any questions on either one of these first two examples before we go to example 3? All right, so here's what's going to happen. I'm going to put the third example up there, and I want you all to try it. Don't type an answer in the chat. Don't unmute and say the answer. Just try the problem on your own, okay? Keep your answer to yourself for now. Please do what we've just been doing. Find the measure of the side length labeled x in the right triangle that is up there on the screen. Okay, if you're following along in the notes, we're on the 4th of the 5 slides, the third example. Please find the value, the length of x. Round your answer to 2 decimal places if necessary. I'm going to give you about 45 seconds here. Okay, do as much of the problem as you can get done before I start. Need to see if you have an understanding of this without me explaining every single step, because let's face it, when you go to do your homework, while you can ask me questions, I probably will not be able to walk you through every problem. So we got to be able to do them on our own. Remember, the first step, you need to identify the hypotenuse. You've got to do that correctly every single time. So make sure you identify the hypotenuse correctly. Then set up and solve the Pythagorean theorem equation. About 30 seconds, and then we will advance. And by advance, I mean I will do the problem, and you can check your own work against the solution. Okay, so again, the first step would find the right angle. We go across the triangle to locate the hypotenuse. In this case, the hypotenuse is x. The other two sides, it doesn't matter which one you call A and which one you call B. So A is 7, B is 17, or those could be switched. It would not make any difference. And C is x. We're going to set up and solve the equation a squared plus b squared equals c squared. Would help if I wrote the equation right. That would be 7 squared plus 17 squared equals x squared. So again, I made sure to give you some numbers here that are not real friendly. 7 and 17 are not exactly numbers that kids are great at multiplying. But 7 times 7 should be something we should all know. That is 49. 17 times 17 is 289. So we have 49 plus 289 equals x squared. We add 289 and 49 together to give us 338 equals x squared. So x would be the square root of 338. Now, when you go to do your homework tonight, the square root symbol is not something you're going to be able to show in your work. So just type out square root of and then the number. Okay? So square root of 338 in our calculator reduces to 13 root 2. At some point we will discuss how to reduce those, but we'll wait till we're back in person. We hit the convert button to turn that into a decimal. That is 18.38, and the third digit is 4. So that 4 tells us we're going to round the 8 down, giving us x is 18.38. And then we just need units. There are no units listed. So what do we write for our units? Nothing listed there. That's correct. We just write the word units. We don't know what units, but we know we're supposed to have units. So our answer should be 18.38 units. Any questions on these three examples now before we go to the fourth and final example? Lovely. I'm glad this is going fairly well. We are going to go to this final example. Now, this final example, and I believe everybody in this class is, well, almost everybody in this class is either a freshman or a sophomore. So one of the big changes that's coming to our lovely state of Indiana here in the next year or two is that you are all going to be taking the SAT as your graduation exam. So to prove that you deserve to graduate from high school. So here is an SAT question that requires the Pythagorean theorem. So I want you to try this problem, and I will explain how this is an SAT problem after we go over it. Once again, I'm going to give you some time to get started. Keep in mind, step one is still correctly locate the hypotenuse. So work your way through this example. Again, I'm going to give you some time to work through it, and then I will start and we'll go over it together to make sure that you've done it correctly. Work your way through that example, please. All right, giving you some time to get out ahead of me. Solve this problem, please. Start by finding the hypotenuse and doing the Pythagorean theorem to find the missing side length. That much of it is the same as the other questions that we have already done. 45 seconds. Almost there. Okay, so we're going to start going through this again. Check your own work against mine. Make sure you're doing this correctly. Again, we look for the right angle. We go across the triangle. That is how we locate the hypotenuse, which is our C. So 25 is the hypotenuse. The other two sides, 16 and X, are your legs. Those are A and B. So in this case, I have A is 16 inches, B is X, which is in inches, and C is 25 inches. Set up and solve the Pythagorean theorem to solve for X. So 16 squared plus X squared equals 25 squared. So 16 squared is 256. 16 times 16 is 256. 25 squared is 625. 25 times 25 is 625. To solve that equation, this is like the second example. We need to subtract 256 from each side, which gives us that X squared is equal to 369, which means that X is the square root of 369. So we take the square root of 369 Our calculator reduces that to 3 root 41. Hit the conversion button. That is 19.209. So we round that off. The 9 tells us to round the 0 up to a 1. So 19.21 inches for x. Now, just show me on your camera. Don't type anything. Don't say anything. Just show me by shaking your head. Are we done? Did we answer the question? No. We found the missing side length, but that's not what this problem says to find. And that, ladies and gentlemen, is exactly what the SAT does. Okay? You cannot answer the question without finding x. You have to find x first in order to answer the question. That's what an SAT question does. Now, most SAT questions are multiple choice, which means one of the incorrect answers to the multiple choice is going to be 19.21. The answer that you need to answer the question, but it's not the answer to the question. See what I'm saying? So then we need to turn around and we need to find perimeter. So how do we find perimeter of any shape? What do we need to do? Type in the chat. You can unmute and tell me. There we go. That's right. Perimeter is where we add up all of the side lengths. So the perimeter of this shape, which we'll call P, is 16 plus 25 plus x, which we said is 19.21. So 16 plus 25 plus 19.21 would be a perimeter of 60.21 inches would be the perimeter of the triangle. Okay? Guys, that's all the SAT is. The SAT is skills that you definitely are going to know how to do, but the wording of the problem is going to be tricky. So if you don't go back and read the question and make sure that you've answered the question that was asked, you're going to get some stuff wrong. Okay? So remember that. You always need to make sure that the answer you are providing answers the question that's being asked. Okay? That is it for the video lesson portion. So let me stop the recording.